In the not-too-distant future, when the threat of ballistic missiles became an integral part of geopolitical reality, the world gained a new means of defense, a laser anti-missile defense system, known as the solar shield. This revolutionary technology was developed by an international consortium of scientists and engineers working together in the field of military security. The solar shield was a network of high-precision laser installations located around the perimeter of strategically important objects. Their task was to detect, track, and destroy enemy ballistic missiles before they reached their target. Each laser installation had incredible accuracy and high reaction speed, making the solar shield virtually invulnerable. The first real testing ground for the solar shield was created in a secret location, where thorough tests were conducted. Soon, the moment of truth came when military trials faced a real threat. An enemy country launched a series of ballistic missiles towards the capital, trying to respond to the new technological threat. The solar shield system came into action. Laser beams accurately and effectively intercepted the flight of enemy missiles, turning them into twinkling sparks in the sky. None of the missiles could overcome this invisible shield, which protected the world from potential disaster. This success caused a wide resonance in the international community, and other countries began to develop their own versions of laser anti-missile defense systems. Soon, such systems became an integral part of the defense strategy of most developed states, mitigating the threat of nuclear conflicts and providing reliable protection from missile attacks. When military reproduction technologies reached their peak, a new laser weapon called Dragonfire shone in the world of science fiction. This amazing weapon was created by the corporation Astraltech, a leader in innovation research in the field of military technology. Aerial reconnaissance specialist Yuri Kazyanov noted that laser weapons are not some kind of Wunderwaffe that just appeared, as engineers have been experimenting with similar systems for over 20 years. Moreover, a weapon system like Dragonfire has its limitations, which just can't make it the perfect solution to all the problems that have accumulated in the combat zone in Ukraine. And one of such weak points is the inability to operate in complex weather conditions. The range of Dragonfire is classified, however. The ministry reported that the complex is a means of hitting targets within direct visibility, capable of striking any visible target. The cost of one shot is about $10, which makes the laser installation more attractive than other types of weapons. Dragonfire was presented as a revolutionary tool for modern wars. Its laser beam, possessing absolute accuracy, is capable of hitting targets at long distances, instantly transforming everything in its path into instant heat and ash. The reliability and effectiveness of this weapon were so great that Dragonfire became a symbol of greatness and power. Each Dragonfire beam was formed and controlled using advanced computer systems which provided a high degree of accuracy. Optical sensors and real-time sensors analyzed the surrounding situation, allowing the laser to be accurately aimed at the target, even in the most complex conditions. However, despite all the achievements, Dragonfire raised some ethical and strategic questions. Discussions were held on how to limit its use and avoid possible abuse. The struggle for control over this weapon became a key element of a new stage in geopolitical relations. The Dragonfire laser weapon became an integral part of the global military arsenal, giving countries the opportunity to maintain their security and protect their interests. Nevertheless, it also underscored the importance of discussing ethical standards and restrictions in the use of technologies capable of changing the course of the art of war. In the future, when drone technology reached its peak, the world faced a new challenge: the threat of unmanned drones used for various purposes, from commercial to military. In response to this, an innovative technology emerged: lasers for combating drones, or Falcon Eye, as it was nicknamed. Falcon Eye was a network of laser installations integrated into various public and military facilities. This network provided continuous scanning of the sky to detect unmanned vehicles. As soon as a drone was spotted, lasers designed to destroy it were instantly activated. The first successful test of the Falcon Eye took place in a city that became the epicenter of massive drone attacks, threatening the safety of citizens and infrastructure. The lasers easily handled maneuverable drones, accurately taking them out of operation. This was an important step in ensuring the safety of citizens and industrial facilities. The Falcon Eye technology was implemented in various regions where unmanned drones posed a serious security threat and disrupted public order. Over time, unmanned drones became more accessible and were used for both military and non-military purposes, creating potential threats to civilians and infrastructure facilities. Regions prone to terrorist acts, smuggling, or other criminal activities became the main targets for the implementation of the Falcon Eye. These regions could include country borders, military zones, cities with high crime rates, or critical infrastructure facilities such as airports, power plants, or important government institutions. Thus, the Falcon Eye became a symbol of a new era in technological military security. Falcon Eye was used to detect unmanned drones, identify them, and in some cases, destroy or disable them. This helped prevent potential terrorist attacks, smuggling operations, or other criminal activities related to the use of unmanned vehicles. Military and law enforcement agencies actively used the Falcon Eye to ensure the safety of civilians and protect state interests. This technology became an integral part of the strategy to combat modern threats and helped create a safer and more reliable society. The implementation of the Falcon Eye also underscored the need for continuous development of security technologies and combating threats, as well as the need to comply with laws and ethical standards when using new technologies for military and law enforcement purposes. In an era when military reproduction technology has reached unprecedented heights, the moment has come when precision strikes have become the norm, not the exception. At the center of this transformation were laser devices for target marking, known as laser designators. These devices were created for the purpose of accurately highlighting objects on the ground for guided missiles and bombs. Lasers integrated into these devices emitted laser beams invisible to the human eye, which accurately marked the target, providing information to the guided weapons. Armed with laser designators, soldiers and special forces operators can accurately point out targets for attack, increasing the likelihood of successful strikes and minimizing risks to the innocent. Military helicopters, fighter jets, and even ground artillery can use these devices to mark targets in real time, making them an indispensable tool in modern combat operations. In the first combat use of laser designators, a bomber crew, creatively equipped with new technology, approached a target that was previously considered inaccessible. The laser designator was activated, and the target was illuminated by a laser beam. From that moment on, a guided missile launched from another aircraft followed the laser-marked target, accurately targeting it. It is important to note that the use of laser designators requires strict adherence to safety rules and compliance with laws on military operations. Improper use or misdirection of the laser beam can lead to unforeseen consequences and harm innocent people. Nevertheless, due to their effectiveness and versatility, laser designators remain an important element of the armed forces of many countries and continue to be improved with the aim of increasing accuracy and safety in military and civilian applications. In the darkness of the night, when the enemy relies on their night vision devices, the optical dazzling light becomes an indispensable weapon. Tactically placed on the battlefield, they have become an integral part of the strategy for conducting operations in conditions of limited visibility. The first experiments with the optical dazzling light took place in real combat conditions when special units were sent on a mission to disrupt the enemy's optical systems. The laser devices were activated, aimed at the enemy's optical devices, and created bright, dazzling beams that exceeded the adaptation capabilities of enemy night vision systems. The results were astonishing. Enemy forces were temporarily deprived of the ability to effectively observe and respond to the actions of our troops. This allowed our forces to conduct successful operations, minimize losses, and achieve strategic goals. However, like any new weapon, the optical dazzling light raised questions about its ethics and use in accordance with international standards of warfare. The introduction of this technology became a challenge not only for the enemy, but also for the global community, which had to define the boundaries in the use of such means. Nevertheless, the optical dazzling light has become a new powerful tool in the arsenal of the armed forces, changing the course of combat operations and giving an advantage to those who are able to control its application. In the era of rapid technological progress, when military strategies are constantly evolving, laser systems for detection and study, or laser rangefinders, have become a key link in providing high-precision distance measurement and accurate coordinate determination on the battlefield. The breakthrough occurred when military engineers integrated powerful lasers into portable devices, allowing the military to accurately measure distances to objects in real time. Equipped with laser rangefinders, soldiers gained a tool that significantly enhanced their capabilities in tactical operations. The first real test of laser rangefinders took place in mountainous terrain, where accurate distance measurements were critical for successful mission completion. Special forces, armed with these devices, could easily determine distances to targets, calculate heights, and obtain coordinates in real time. Laser rangefinders not only increased the accuracy of military operations, but also made a significant contribution to scientific and civilian areas, providing accuracy and reliability in measurements at all levels. Lasers can also be used for data transmission and communication between different parts of an aircraft carrier and other military objects. Unlike traditional radio wave communication systems, laser communication systems use laser beams to transmit information. The advantages of laser communication systems include 1. High bandwidth, which means the ability to transmit large volumes of data in a short time. 2. Security and protection. Laser beams can be directed precisely and can be easily directed in a specific direction, making them more secure and protected from interception than radio wave systems. 3. Low latency. Laser beams transmit data almost instantly, making them an ideal choice for applications requiring minimal latency. 4. High accuracy. Laser communication systems have high accuracy and resolution, allowing data to be transmitted with high precision and reliability. Wireless optical systems are based on technologies for organizing high-speed communication channels using infrared radiation, which make it possible to transmit data, text, sound, graphic data between objects through atmospheric space, providing an optical connection without the use of fiber optics. The laser communication of two objects is carried out only through a point-to-point connection. The technology is based on the transmission of data by modulated radiation in the infrared part of the spectrum through the atmosphere. On the receiving side, the optical system focuses the optical signal on a highly sensitive photodiode, or avalanche photodiode, which converts the optical beam into an electrical signal. The signal is then demodulated and converted into output interface signals. Laser communication opens up new possibilities for space missions, as it allows for more data to be transmitted in less time and with less energy consumption. This can accelerate discoveries for researchers, as well as improve communication and navigation for manned and unmanned missions. NASA plans to use laser communication for future missions to the Moon and Mars, as well as for studying other planets and asteroids. Thank you for watching the video to the end. Join our channel to stay up to date with all new releases and not miss interesting materials in the future.